Hello students, welcome to the third video lecture of Chapter 1 Physical World. In last video lecture I left you people at electromagnetic force, that is one of the fundamental forces in nature. Before this video lecture we have studied two fundamental forces, those are gravitational force and electromagnetic force. Now in this video lecture we will proceed with the third fundamental force, that is a strong nuclear force, right? So what is a strong nuclear force? The strong nuclear force operates between nucleons. Nucleons means what? The constituent particles of the nucleus, like neutrons and protons, they are called as nucleons, right? So these are the properties of strong nuclear forces. The first one is it operates between nucleons. It may be attractive or repulsive, because between proton and proton a repulsive force will act, right? Next, its range is very short within nuclear size, because it acts within the particles of the nucleus. So that's why its range is very short. Equal to 1 Fermi. Fermi I have discussed in the last video lecture. 10 to the power minus 15 meter, right? Next property is its strongest force in nature. So these are the properties of strong nuclear forces. Okay. Next, the fourth fundamental force is weak nuclear force, right? Weak nuclear force properties, let's go through. First, it operates between nucleons, that is elementary particles like electron and neutrino. Okay. Other than neutrons and protons, so many fundamental particles exist in the nucleus, like neutrino, antineutrino, mesons, pi mesons. Okay. Pi plus meson, pi minus meson, pi zero meson, so many fundamental particles. These fundamental particles we consider to understand the formation of the nucleus and design of the nucleus, right? Next property, it appears during radioactive beta decay. Third property, it has a very short range, equal to 10 to the power minus 15 meter, again equal to 1 Fermi, because it acts within the particles of the nucleus. Next, the last one is 10 to the power, this force is 10 to the power minus 13 times than the strong nuclear force, right? This is 10 to the power minus 13 times, so definitely it's weaker than the strong nuclear force. That's why it is called as weak nuclear force. And remember, the strong nuclear force is the strongest force in nature. Among all the fundamental forces, the strong nuclear force is the strongest force, right? Next, conservation laws. This is the last topic of the chapter. Previously also we have studied so many conservation laws: conservation of momentum, conservation of energy. So these come under the conservation laws. Let's go through. In any physical phenomena governed by different forces, several quantities do not change with time. These special quantities are conserved quantities of nature. So the quantity which does not change with time, that quantity is said to be conserved. Okay. Or it can say, like in class 9 we have studied the conservation of momentum, states that if momentum of the body remains constant with time, so that is called as conservation of momentum. Okay. Let's read out some points about the conservation law. First, for motion under conservative forces, the total mechanical energy of a body is conserved, okay, or constant. This is conservation of mechanical energy. Second point, the total energy of a system is conserved and it is valid across all domains of nature, for microscopic to macroscopic. Total energy of the universe is believed to be constant. Okay, conservation of energy. Okay, energy is conserved. Next, conservation of mass. Conservation of mass was considered another conservation law till advent of Einstein, means before Einstein's concept. we were separately studying the conservation of mass and conservation of energy, but after the Einstein's entry, we study the conservation of mass energy. It means mass energy conservation together. Then it was converted to law of conservation of mass plus energy. Just now I have told, and same thing is written over here. Okay, conservation of mass plus energy, because mass is converted into energy and vice versa according to equation E is equal to mc square. This is the energy mass equivalence relation. After the entry of this relation in the physical world, we consider the conservation of mass plus energy, because energy can be converted into mass, correct, or mass can be converted into what? Energy, right? Next, momentum is another quantity which is preserved. Similar is angular momentum of an isolated system, right? Momentum and angular momentum. Angular momentum you will study in the same class in chapter number 7. The chapter's name is System of Particle and Rotational Motion. In rotational motion, we study the angular momentum. There we will study the conservation of angular momentum. And conservation of linear momentum we have already studied in class 9. P is equal to mv. You might be remembering the formula. Okay. If m1 u1 plus m2 u2 is equal to m1 v1 plus n2 v2, if two particles or two bodies are colliding, then it is called as conservation of momentum. So there we studied the conservation of momentum. More precisely, we can say the conservation of linear momentum in class 9. But in this class, you will also study the conservation of angular momentum, right? Fifth one, conservation of electric charge is a fundamental law of nature. Okay. Conservation of electric charge is also there. We will study in class 12, the first chapter, electrostats. So there we will study the conservation of electric charge. So you can see so many conservation laws are there. Point to point, these laws are written. In short, we have gone through all these laws, though these laws are elaborated in different chapters in different classes, but in short it is given. It is just for the introduction, right? At last, we study the note point. The laws of nature do not change with change of space and time. This is known as symmetry of space and time. Okay, this and some other symmetries play a central role in modern physics. Conservation laws are connected to this. Clear? This is the note point about the conservation law. You should remember it. Okay. The thing which is written over here, the laws of nature do not change with change of space. It means it is universally correct. It does not change with change of space. And this is known as symmetry of space and time. It means time and space both are symmetrical. The laws do not change with the space. Therefore, they are universally correct. Again, I am repeating. Clearly? Clear? Now, we have finished the chapter 1, physical world, with the topic conservation laws. I would like to say over here that these things, whatever you have studied in this particular chapter, they are a very short introduction of all the topics. We cannot understand fully in one chapter all these topics, because these topics are given in different classes, different chapters in elaborated mode. So we have to wait for that particular time when we will study these different topics in explanatory mode, right? But for the time being, you have to prepare the things which we have studied in chapter 1, right from the science to the conservation laws. Hopefully, whatever we have studied in certain parameters, you have understood, and now you will start to revise all these things and you will start to prepare chapter number 1. Prepare the notes also, maintain your copy, update it and keep it ready. Now, I want to say all the best to everyone, those who have entered in class 11th, and keep on studying, keep on working hard, Thanks a lot.